let's get started. So thanks everyone for coming today, Friday. Good to see everyone this morning. So your room's not quite as full as normal. I don't know if it's because of the assignment or what, but you don't have to super spread out, right? You can always, everybody says that, but nobody does it actually. So, even in faculty meetings, the faculty spread out like crazy. It's really fun. Okay. So questions on assignment 1? Before I get into this?
Maybe say something about the small packages.
Yeah, I will.
Okay.
I was going to see if there's any other questions. Any other questions?
We can use the regex package like when using Python.
Yes, you can use the regex, but absolutely. The only thing you can't, the only packages you can't use are anything that does HTTP parsing.
Okay.
Right, but you can use regular expressions to parse it. You can use the URL library to parse the URLs. Yeah.
What if we use a part of the HTTP library that doesn't do the actual HTTP call?
You should ask me if it's okay. Yeah, so I can make sure. Yeah.
Does it have to handle multiple connections? Or can it
Does it have to handle multiple connections? What should a server do?
Multi-thread.
Yeah, it should handle multiple connections. Right? Because the idea is you're creating a server that's a backdoor, right? So if you have the server and when you connect to it, you have it do some long-running job in the background. When the administrator scans it, right, you don't want that thing to crash or to fail or to not respond to that connection. You want it to respond and say, hey, no, 404, like look elsewhere. These aren't the droids you're looking for. Okay, some things that I posted. So I posted on here the list of apps, of Ubuntu packages that are installed on the submission system. So this is all of them. If you know any discrepancies, please tell me. I can fix it. You know, it's easier to fix it now rather than an hour before the due date, right? So, you know, a bunch of junk, not junk, sorry, a bunch of stuff on here, right? So if you need to see if your package that you want is on here, you can easily look on here. There's the link. I also sent a, so we can, here is the link of all of the, trustee packages. So trustee is the Linux distribution that we're using, right, 1404. So you can go in here, you can find your package, you can look, you can grep. All right. So the submission system is up. It's not all the way up, it's about 90% up. Wow, depends on your perspective. So you can create an account, right, which you should do. All of your ASU IDs, if you're registered for the course or have been registered for the course, should be in here. If you have any problems or it's not in there, please let me know. Or if you're here illegally and not actually involved in the course, but you want to get an account here, I'm totally happy to do that. Just send me an email, I'll add your ASU ID on there. You should come up with a hacker alias, a cool hacker alias for later homework assignments. We'll be posting maybe some scores or rankings or how people are doing throughout the week, so we can see who's hacking what systems. And so this is a checkbox you can use to say if you want to obfuscate that on the public. If anytime your hacker alias is public, it'll be obfuscated. So you can be creative, choose a cool hacker alias, and then a password. So I'm going to say this now. So I created this system. It does the bare minimum it needs to do so that we can test your projects, right? So did I do things like implement a password reset mechanism and email you your password thing? No, I did not. I'm fairly certain, since it came out on the mailing list, I'm pretty sure that I am hashing very well all of your passwords, I think with bcrypt, so that should not be a problem. But that means that I can't, and I think it is salted. I think bcrypt, automatically does that. So, so I don't know your passwords. If you email me and say, I don't know my password, then I have to manually go into the server, create a new password, and change it. I'll probably ask the TA to change that at some point so it's a little easier, but, So should you use your Gmail password on here? Why not?
Shouldn't use the same password on multiple sites anyway.
Yeah, what if I'm lying to you, right? And I'm logging all of your passwords to break in your Gmail accounts, right?
It's not HTTPS.
It's also not HTTPS, yeah, because that's a pain to set up. I'll try to do it at some point, but This is just for your submission things, right? It's just to keep you all out from each other so we can tell you all apart, right? Cool. All right, so once you create an account, you'll be able to log in, and I just realized I'm in the wrong browser because I don't know the password here. Also, so I did say, okay, well, I'll get there in a second. Let's see if this login works. Yes. Okay, this is my awesome hacker alias. So you can submit assignment 1. So the only thing that's working right now is the smoke test, because I had to, basically I created these to do the smoke test for my system to make sure that you could submit things, they would automatically get assessed, all that kind of stuff. So I can, let's see, this is for my 591 class, so this should definitely not compile. You can submit a make file, and then you can submit as many source files as you want. Let's go here, like that. I can do a smoke test. It'll tell me that yes, it was successfully submitted. The smoke test had 100 submissions. I don't know, it doesn't really matter. I can change that at any time. And so then I can check the status, and it's going to say that it's submitted and it's still pending. When it actually gets some output, it'll tell me the output. It'll tell me it failed to compile the project, and here's the first 750 characters from the output. Characters output from, that's not right. So this will tell you what's wrong. It'll help you try and debug your program. And if we refresh, I don't know exactly how long this takes because I haven't timed this yet, but at a certain point this will stop and it'll give us output for this submission, or everything crashed, but hopefully it does it in a way that we will never know about this because you don't know about it. There we go. So you get feedback pretty quickly, and you also notice there's no fancy like, oh, it's in progress and there's not much time remaining, right? So, you know, you gotta give it some time. So yeah, it tells me that it tried to make, but it failed. So it tried to do this copy thing, and it tried to look for a discovery file, and the discovery file was not there. I can probably add that information in here. We can see here in this test case, when it tried to execute discovery, right, that didn't exist because I submitted a make file for a completely different project to do a completely different thing. So very soon, definitely by the end of this weekend, I'm gonna have a way for you to take this smoke test submission and then submit it actually for project 2 so it can actually be evaluated with the real test cases. So that'll happen soon, but this will install, it's exactly the same process. So it's gonna install all the packages you install, it's gonna compile it just the way we said on the website, it's gonna do everything. So that way, when it passes these 2 cases, then you know you're at least good to go, that your program actually compiles. All right, any questions on this? It's pretty basic, it's not super complicated. If you have any problems, email me. There'll be problems, I'll head that off now. There's always problems. But we'll be able to solve them together. Okay, important note about this IP address here. Oh, alright, I can't zoom in. Okay. So this is the IP address of my lab. 192.219.253.30. So do not scan or run any things against this lab. Right? So this IP address is the external facing IP address for our entire lab and all the research that we do. So the IP address is not fair game. The IP address at this specific port is fine. It's forwarding to a server in our cloud where all this submission stuff is running. So if you find something on that or you find something in the website, please let me know, right? Be an ethical security researcher. As long as you're making a good faith effort to not, break into your fellow students and get their submissions and submit them as your own, or otherwise interfere with their submissions, right? Then I think it's good. So this is a place you can play around with and try to bang on. So I don't know. I tried to code it very securely, but we'll see. Stuff happens. The one thing that's definitely not really fair game, although I don't think. So the submission system. So we're taking code from you and actually executing it, right?
Right.
Right? Which is actually what you want to do oftentimes when you're exploiting something, right? You want to get a foreign system to execute code of your choosing. We are doing that here. So, use this responsibly. So, I think I've set it up pretty well so that you shouldn't be able to mess around with it, but, those systems are running everybody's submissions, right? So if you mess one of those up, then you've messed up that system for everyone else. So don't, if you do something really cool, like you're able to exploit the Linux kernel or something and get root on that machine, that's really cool, you should let me know. But if you're like running code on there to figure out the hidden test cases and then send them to you on TCP or an email or something, like that's not cool. That's like, you're breaking the assignment, not the actual security of the system. Like, yes, we all know you're running code there. You can do whatever you want, right? But the point is actually implementing the assignments. So, is that clear? Kind of fair rules. If you have any questions, just let me know. I'll be happy to talk about it. All right. All right, looks like it worked. Okay. So we've looked at so far, we've looked at how the network works, how networking works. Does this look dark to you guys too? Yeah, this is the same problem that happened before. Let's see if just plugging. So you do see that it's dark on the sides? The system would allow that or cause that to happen. All right, we'll try this one more time. Yeah, maybe I accidentally did that. That's the resolution. I think the resolution switching between it definitely does not like. Okay, good, a little distraction. All right, so we've talked about how networking works, how packets move on our local network, right? What does it mean? What does a local network mean? Is that just like a vague term? Like, I don't want to say any other things, but does it mean something? What does a local network mean?
In the same subnet?
Yeah, we're on the same subnet, right? So when you configure the IP settings of your machine, right, the subnet says, hey, any IP address that's a prefix or within this subnet is on my local area network. So I know I can directly talk to any other machine on my subnet. Okay, so we talked about that, right? And we haven't even gone into how packets traverse the interface and how they get out, right? We've only been looking at local area networks. And we've talked about why do we want to, we've talked about sniffing the network, right? We want to sniff the network, we want to be able to get information that we shouldn't be able to get. And so this is what we're going to look at now. So network sniffing is the start of a lot of local area network attacks. The basic idea is that, so by default, what's actually getting the packets on your machine? Right, your IP packets come into your machine, and what are the layers it goes through?
Through the network card.
Through the network card? Yeah, so the network card first, it maybe does some processing, then throws it up to the kernel or the hypervisor, depending exactly how it's done, probably up to the kernel, and then the kernel sends it to you, the application, if you're listening on that, right? So by default, what is you're making an efficient network card, right? What are you going to do if you get a packet that's not destined for your physical MAC address? Drop it, yeah, right? You know you're not going to do anything with it, right? So you just drop it on the floor. You ignore it, right? Which makes sense because it's efficient, and the physical card knows its MAC address, right? But they, if you're debugging or any kinds of these other things, right, you actually don't want that. You want to see all the packets that are on the network. And so there's a way to set your network interface into what's called promiscuous mode, where it actually will pass up all the packets that are not destined for that specific MAC address. And then it's up to the other layer to decide what to do with it. So the operating system has to decide if it deals with that packet or not, and or your application. So, is this it? We just say, bang, we set this little bit, this mode on our network card, and now we're good to go, we can sniff everything.
If the packets are encrypted, I guess.
Encryption, non-encrypted, we don't really care about that at this point. We still have to read it to know if it's encrypted, right? Right, we still need to be able to read it at some point. So can we sniff everything we want now? What are we talking about on networks? What do we know about how local area networks work?
It's sent to every packet sent to every other computer in the local network.
Every packet is sent to every other computer on the local network.
That has to first establish a connection to to every other institution.
Right, so we have ARP, so remember on ARP, right? So when we want to know somebody's physical address, we broadcast a message to everyone in our local network. So are we gonna get those packets when we set ourselves to promiscuous mode? Yeah, by default, it's broadcasting to everything in the subnet. So those messages are coming physically to our car, right? So we can listen to them. Right? That's one thing. But can we just listen to any other arbitrary packets?
That are being routed via me.
What was that?
That are being routed via me, I could listen to all of those.
That are being routed via you, yeah. So what were the two architectures for a local area network, like the physical devices? Switch and hub, right? So does that affect what you can sniff?
Yes.
Why?
In hub, actually,
What was that?
in hub they'll broadcast to everyone.
Yeah, exactly, right? If you're on a hub, you're done, right? Everybody's packets are coming to you anyways because you're on a hub. So all those packets that you're getting in, as long as you're in promiscuous mode, you can read them, right? You can see exactly what's going on in the network. But if you're on a switched port, or you're on a switched network, right, it becomes more tricky. Because by default, packets destined for another MAC address don't go to your port, right? The switch keeps track of what MAC addresses are coming from which ports, and so that way it only sends out on that port. So we're gonna look at that. So we talked about a little bit about kind of high-level why sniffing. Some of the other reasons why you want to do sniffing, because aside from it's just really cool, you can steal financial information. A lot of protocols that are still in use nowadays transfer authentication information in the clear. So if you ever connected to an FTP site where you had to do username password, that username password is sent on 100% in the clear. Same with POP, same with HTTP, with basic authentication, actually with all of the types of authentication. It's still sent over in the clear. IMAP, what's POP and IMAP? Yeah, reading email, right? SMTP is the Simple Mail Transfer Protocol for sending me email. Don't remember what they stand for. Anybody know off the top of their heads? POP and IMAP?
Post office
Post Office Protocol and what's the other one?
internet
Message of
That actually makes sense, okay. Post Office Protocol and Internet Message Access Protocol. Not very inventive names. So, because these protocols just send it in the clear, right? And this isn't a class about encryption. You can learn about how to break encryption, all that stuff. But here, we're not even talking about encryption, right? They're not even being encrypted. They're just sending it out. So we can actually collect usernames, passwords, files that are being transferred, mail, and oftentimes we'll save that data to a file and try to analyze it later to look for these things. And this is stuff that happens all the time. Like you think, well, we have SFTP, right? You can do that securely. We have HTTPS. We have, you can do POP or IMAP over SSL, so all that's encrypted. We've actually seen this when I was doing a pen test at a company in Santa Barbara. They gave us a tap on all their network traffic, and we were listening to it, and we saw that somebody was using an FTP server and was sending the username and password in the clear. So then when we connected to it, we were able to see that they were, it was their, I think it was one of their marketing people, had like a little marketing site that was up there. And so once we got in, we could like poke around in there, and we could have uploaded files and changed all that stuff. So, you know, this stuff happens all the time. You'd be very surprised by this kind of stuff that happens. Okay, so I was gonna say we could do it, we could sniff on the network ourselves, which you can do, but there's a lot of layers in between you and the packets. So there's a lot of tools that actually help make sniffing a lot easier, and they're good for hacking, penetration testing, trying to understand, and really also for trying to understand what's going on in the network. So really, if you ever encounter tricky troubleshooting network problems of why isn't this packet, this request getting to this server where it should be getting, these are the kind of tools you look for. Really good command line tool, the most famous, best one in my opinion is TCPDump, which collects traffic. So You can set filters on it, as we'll see, to change which types of traffic. TCP flow will take in a TCP dump file, analyze the TCP connections, the flows, right? So TCP connection, we're going to get to it, but it's IP, source port, destination port, right? And that constitutes a flow. And so it's able to take from the TCP dump and rip out all the flows into separate files so that you can see all the communication that's happening in there. TCP replay is a super fun tool to play with because it will replay TCP dump traffic to another host. So you can try to record something, maybe try to play it against your own system or back at them or something like that. Graphical tools, Wireshark is kind of the standard graphical version of TCP dump. It will look at the network, see what's going on, and then try to reassemble from the raw IP packets into TCP flows, and it has all support for all kinds of other protocols to then say, oh, this looks like an HTTP, that means this whole conversation is HTTP, and so I can parse it, and I know exactly that this is the sequence, the mode and the request and the URL that's being requested, and this is the response with the response code, all of that stuff. Okay, so TCP dump is really kind of the core. It's a simple tool, but used all the time. And it's based on the important thing, kind of one of the important things here is that it's actually based on a library, so it uses this library, Libpcap, to actually do the network capture. And the idea is you can code your application against Libpcap, and then you can run it on Windows or on Linux or on the Mac or whatever, any operating system. And Libpcap is platform independent. It'll be implemented to do the packet sniffing. Also really cool is that you can specify an expression that defines which packets have to be printed, or to which packets to print or capture, or how to print, how to capture. Very useful stuff for winnowing out everything that's going to be in there. So we talked very briefly about that you need to set promiscuous mode on your network interface. So can all of your programs do that? If any program that's running on your machine, can it set promiscuous mode on your network card?
Does it require sudo?
Does it require sudo? Why would it require sudo?
Because it's part of the hardware.
Because it's part of the hardware? No. You touch the hardware a lot though through the operating system that doesn't require sudo, right? Or root, elevated privileges. But why would you need it? Do you need it? Yeah.
An application might be binded to a port you want to listen to, so sudo might let you stop that and bind to that.
Exactly, yes. So this is actually a little forward preview, but you have two applications running as two different users on your device or on your server, right? By default, they can't access each other's memory, they can't read each other's files unless it's explicitly allowed, right? They have privilege separation. And if it's a network application, right, it's probably reading on a certain port, waiting for input files. So now if another file without any privileges can just listen for every packet that comes into the network, well now I've got all this other data, this other application's data and everything that comes in there, right? So you're essentially being able to elevate your privileges up from a normal application, a normal user, to higher privileges. So that's why TCPDump requires root privileges to be able to set the interface to promiscuous mode. One way to do this is you can have TCPDump output a file, and then you can use TCPDump later as a non-root user to not have to do this. Cool, so let's look at an example. Still held up and everything's recording. Oh no. Okay, this is the homework submission server. Oh, I should update that. It's not a good thing to show everyone. Alright, so I can run, so first I have to tell TCPDump what interface I want to listen to, right? So on Linux, ifconfig shows you all the interfaces that are configured, and by default it shows you the interfaces that are up, right? These are the physical links. So this says Ethernet 0, it has this hardware address, so what's this hardware address? MAC address, exactly. And the, we have the internet address here. What's the mask mean? We didn't really talk about it. How's that mask related to the networking?
Subnet and host, network and host.
What was that?
The starting to bits would be for networks and ending to would be for the host.
It's related with the subnet thing, like how much bits are reserved for the subnet.
Yeah, exactly. So the mask specifies, so the ones, right, 255 is all ones. Those specify the subnet range, and the zeros are the individual hosts in the subnet. So this means I'm on the subnet 172.21, right, and anything below that is on the same subnet. So I know I can broadcast packets there. So now if I just do TCPDump, I'm actually kind of worried I'm doing this in front of everyone. That's gonna break. We'll see. Okay, I use the -I option to specify exactly which interface I want to be listening on. I'll do Ethernet 0. What's the low LO?
What's loopback?
What's the loopback code? Is it a physical? It's like a physical loop. I don't understand.
To send to yourself.
Yeah, it's like a kind of a, I don't know, pseudo device is exactly the right term, but basically if you want to send a packet to yourself, you can send it out to that device and it will just stay on your local machine within the operating system. It doesn't go out to the network and try to do the ARP thing to figure out how to get back to itself.
You can add verbal.
So if I run this, right, what does it tell me? I don't have permissions, right? I tried to ask the operating system, hey, set the promiscuous bit on Ethernet 0. And it says no, because I don't have the permissions to do that, right? So I have to run it as sudo. What does running as sudo do? As root, yes, it executes it as root. So we'll get into exactly what that means. If you think about it, if you're only used to Windows systems, right, root is basically the administrator. They have full access to the machine. So we can run TCPDump with sudo. All right, and it's going to give me some output. Okay, good. I was waiting for it to give me a lot of output. Okay. So then it's giving me a whole bunch of information about this network, right? It's telling me that it's, that there's, and this is, let's see, okay, so part of the problem is, so you see these IP addresses? Or this is the host name, right? So it actually will try to resolve IP addresses and turn them into host names for you to be nice. Honestly, they get in the way a lot of times. So I usually use this -n to say, don't do that.
And -v also.
We'll get that.
You only need verbal, so try to reduce.
Perfect. So then I can see here, so these are timestamps, and these are the type of packet. So we can say at this time, there was an IP packet from, why is there 4? Why is there 5 octets here?
Port, yeah.
What was it? For port. Yeah, the last one is the port. Exactly. So it's saying that IP 172.21.076 at port 22 sent data to, so that's the directional, 1090.64.9 on this port, and these are the TCP flags that were set, the TCP sequence number, the ACK number, the window, any options that were set, and so we can see that there's probably an ACK, there's an ACK back on this connection to know that we actually got the data and that it received it. We're getting some, anybody know what an MBT packet is? It's not a rhetorical thing, or I mean, because I don't know. We see other UDP packets, like this is running an OpenStack network. I don't know what other stuff's happening here. We can see here, very interesting, right? We see an ARP request. So it's saying that, right? So we saw this in the slide. So here we have a request for, hey, 172.21.068. Who has that? And if you find out, tell me at 172.21.024. And we can see there's a bunch of stuff here. So what's this? What's port 22?
FTP? SSH. Oh, SSH, sorry. Yeah.
SSH. Yeah, SSH. I think FTP is what, 20 and 21 or something like that?
21.
22. There's 2 ports because
SFTP is the 21.
No, there's a, FTPs is a data and a control port. So there's like 2. I don't remember exactly what they are. So 22 is SSH. So what is this traffic that I'm listening to? Who's SSH? Did I just stumble onto somebody's awesome
because you have SSH to that device.
Yeah, it's me. I'm SSH to this machine, right? This is my SSH traffic. Clearly don't want that, right? It's kind of boring. And actually it'll just go forever, right? Because every time TCPDump outputs something, it sends data to me, to my machine over SSH, which means it's going to create a new entry in TCP, right? Which is going to keep going forever and ever and ever. So then you can add options to the TCPDump to say, let's say we don't want port 22. So now this is showing me every non-HTTP packet. So ARP, good, we got a reply. Okay. Yeah, so we say, we have ARP, where's that reply? It's there, somebody said there? Down? There we go. Yeah, so we can see an ARP reply, which probably I think was us, we're 172.21.076. But, right, we can see all this data. All this is happening constantly on the port. That's why when you look at the servers, right, they're constantly flashing. And it's all this stuff. It's all these packets, ARP packets, every kind of packet happening on the network. Yeah, we can even do, if we want more information, I don't remember what just doing -v does. Oh, that debugs the protocol more. So yeah, we can break down the protocol more. We can, let's see, if we do, I think X will show us the actual Ethernet, the first couple bytes of the Ethernet of the packet itself. So we can actually look at the bytes and then look at them in text value. Oh, this is weird. I don't know what that is. You can learn a lot of stuff here. Oh, isn't it okay, whatever. That's an IPv6 packet. See, lots of stuff in here, right? Lots of stuff happening on the network. That's why they're super complicated. All right. So it has all kinds of things, all kinds of options. The ones I use are usually -n to not translate the names from IP addresses to domain names. It also actually delays the TCPDump output while it's trying to resolve all these IP addresses, so it's generating more traffic. You can print it in hex. You can use a specific network interface. You can repackage from a file. You can write to a file. The -s option is really important. It used to be that by default it would not capture all the packets. Why wouldn't you want to capture all the packets?
It's too much traffic. You can bring down your server.
Yeah, it could be too much data, right? You're trying to sniff on the network and it's just generating so much data. But the problem is if you're trying to, I've heard stories of people trying to do experiments and trying to do data capture, they forget the -s option, and then they end up only capturing the headers of all the data, which is only about 60 bytes or something, and you've lost all this really important data that you can't get. So actually the default now is to capture all, so the default switch. So it will capture all traffic unless you specifically tell it not to. Then you can specify a file for that filter expression that we were writing, the not port 22. And this is the key. This is where,
But the frame body for the IP packet was 1500 bytes. Why would you want to set it to 65,000?
Oh, the Ethernet? You may not be on Ethernet.
I see.
You don't know what it is, yeah. Because an IP could be that big. Cool. Okay, so those filter expressions are really important. You can define some kind of qualifier like a host. You can say where the host is a certain fully qualified domain name. TCPDump will resolve that for an IP address. You can sniff certain subnets. So you say you only want this certain subnet, certain ports. The direction you can specify, I only want to sniff packets that originate from host Errol. Or you can say destination, I only want packets that are going to a certain host. You can say both. And I'll kind of skip over this. It goes faster, but you can specify the protocol. So if it's an Ethernet, I only want to capture Ethernet packets. I don't want anything else that's different. IP, ARP traffic, operators. So you can use and or not to develop as complicated of an expression as you want. And the important thing here is that it's going to filter it from your file, which can be handy if you're capturing on a system on the command line, and then you want to take that file, transfer it to your local machine to use Wireshark to then look at that traffic. There's other kind of special characters you can see if it's a broadcast packet. It goes, crazy as much as you want to do. The other thing, really cool thing, is you have access to the raw packet data. So you can say, give me all packets where a certain byte or bit is set. Like you can say, IP datagrams with options. So you can say that IP0 and it with OXF is not 5, and then you can see all the IP datagrams that have options set. And so there's all kinds of stuff you can do, putting it all together. This is TCP dumping on the interface, not resolving the domain names to domain names, and -X, as we saw, prints out all that hex, all that packet info. The -W is writing out to a file. R is just reading from the file. So what's the difference here between the $sign and the hash or the pound? What's it? Hash is sudo or running as root. Yeah, exactly. Right. So that's why there's no sudo in front of there. So in the examples, I'll try to keep that up. That's kind of the convention. Is when you're on a terminal or a shell that is running as the root user, right? You want to know so you be careful and think about what you're doing, right? So this is the way to do that. Yeah, we can set an ARP packets where the 7th byte is a certain value, or byte is a certain value. So it's actually built on, the really cool thing is it's built on this library, Libpcap. So you're actually not just limited to using these pre-made tools, right? You're all programmers.
Yep.
Nod your head, yes? Yes? So you could build your own TCPDump or your own, whatever you want to do, your own sniffer using Libpcap. It has a whole bunch of options I'm not going to get into. You get actually the raw packet, and then you can do whatever you want to it. You can read all the bytes, you can alter it, change it. You can cast it to an IP packet to then understand what it looks like as an IP packet, all that kind of stuff. Yeah, we can skip that. Cool. Okay, so this allows us to sniff, right? So we said, okay, but all those packets that we were just sniffing were basically for my machine, right? There weren't packets destined for anybody else, really, or that we saw, right? It didn't allow us to eavesdrop on somebody else's conversation, right? It was only broadcast, because presumably that system is running on a switch network and not a hub-based network, right? Because hub would just broadcast everything out. Okay, so what can we do? If you're on a switch network, right? You want to be able to sniff all the traffic. You want to be able to get all the traffic. So what can we do? Come up with attacks. You're hackers. Yeah, in the back.
You can mask your max to be the one, to pretend to be the receiver.
Yeah, you could say mask or just change your Mac basically to be that receivers. Yeah, so you can impersonate them, get some of the traffic. Yeah.
Look at all the ARP requests and come up with all the hardware that's all the MAC addresses for all the other machines, and then use that to kind of replay it to the switch.
Yeah, you could do something like that. What do we know about a switch? What are some things we know? Think about it.
It's a layer 2 device, so we can change the ARP table entries.
It's a what?
Layer 2 device, so
What was the first word?
layer 2.
Layer 2 device.
So we can change the ARP table entries.
It's a device, right? I mean, the important thing is it's a device. How much memory does it have?
Oh,
A limited amount, right? Compared to your machine, right? I actually don't know. It'd be interesting to look at how much memory they have, but it's probably safe to say it doesn't have 4 gigs of memory or something like that, right? So what if we just flooded the switch with a bunch of MAC addresses, right? We made it, right? It's keeping track, just like you guys said, right? It's keeping track of all the ARP tables on the switch itself, right? It's mapping ports to ARP MAC addresses. So what happens when that gets really big?
the switch.
The what? It could overflow. Yeah, so you're a switch maker, right? Put yourself in Cisco or Juniper or whatever shoes, right? You make a switch. What do you do when the switch fails? Reboot? Could be one thing. What if it happens again? What's another thing you could do? Or like an engineering thing?
So the package that are like 5 days back.
I don't know, we're thinking about the switch from the switch's perspective. Like the switch itself, like an engineering kind of thing, right? So, or even a business thing. Right? Should the switch just crash and shut off?
Nope.
Why not? So what's about your product if you just got a lot of traffic and you ended up crashing, right? Like, it's a crappy product. Yeah, gonna hand it back.
Drop the packet. You should drop those requests. The
Yeah.
like you said, it's called as an active record or something like active list. I'm not too sure about the name, but it keeps dropping it based on the number of traffic that's actually flowing to that particular IP address. It prioritizes the IP base.
That's more like a quality of service kind of thing of how to ensure fair bandwidth allocation in the switch, right?
But they drop packets if they're not being used. So even if you are going to dump so much on it, but
Yeah, but I can make packets really fast. Like I send out thousands of just independent MAC addresses on the network.
the active record list is actually the memory is limited, so it's going to remove whatever's there on it and then flood it with whatever you have.
Maybe it does, maybe it doesn't. I mean, it depends on the system. It depends on how they coded it. But in general, right? So, yeah.
Does it become a hub if it can't find a match?
Yeah, right. You want it to just still work, right? Forget all the switching stuff. You know, it can work just as a simple hub, right? And it'll keep working. Yeah, exactly, right? So, hey, then it crashes, whatever, something, don't care, it's still gonna work. But for us, we can actually use that to our advantage if we know the switch is built like this. We can flood the network with MAC addresses, send out a bunch of packets. It's maintaining this mapping, right? And in some, I'm not claiming this happens in every case, right, with every system. But
So you're saying that it will not maintain the ARP table and directly forward to the.
yeah, it'll just crash, right? I mean, it can't, whatever, any error happens, and I don't know if it's running exactly an operating system or embedded system or whatever, right? But an error happens, well, you don't want to stop shuttling packets around, right? But let's just switch into a hub mode. So this would be one way, right? So you just basically force the switch to turn into a hub, right? Which is pretty cool. So you're basically using the fail state of the device, and because it can fail to a hub, and yeah, you have a performance degradation, but it's still working, right? So from a safety, reliability standpoint, that makes sense. But from a security perspective, right, now we're able to transition that device into an insecure or less secure state so that we can now sniff all traffic. Yeah, no, back.
What if secondary switch comes into play when this goes down?
What happens if it's, you have other issues to deal with. Yeah, then it wouldn't be a problem. Or it'd be like, what if it just drops the last MAC entry? Like, what if it's kind of like saying, what if it's coded correctly and it doesn't do this? Then you have to try other things. That's what we'll look at. So the other thing we look at, right, somebody said earlier that, well, we just duplicate. We can actually listen to all of the ARP broadcasts, and we can make our own list of IP addresses and MAC addresses, and then we can send out on the port that, hey, we're at this MAC address, right? We can send out packets so that way it associates the victim's MAC address with our MAC address. And so ideally the switch will record this in the table and send that traffic to our machine or both machines, which would be really good because then that machine doesn't know we're actually doing anything, right? If they don't know that they're missing packets, well, then it's coming to us and we're good too. But part of the problem there is then we come into this timing game, right? Like, but as soon as then that other machine sends out a packet, right, then the switch is going to put that entry in its table, associate that port with that MAC address, and then when the reply comes back, it's probably going to go there. So we either have to do this a lot and continuously, right, to make sure our entry's in there, but then we've kind of taken that other machine off the network, right? Because that machine can't really talk to anybody because it never gets a reply back, right? It tries to make a request, all replies go to us instead of them. And so, yeah, maybe we sniff a packet and then stop, wait for it to reply and then go again, but then we're still missing the packets also that it's sending, right? We're not getting any packets that it's sending out. So this definitely is an option. It has some problems. So what do we know about the ARP protocol? Yeah, it's a broadcast, right? So let's think back to how it works. So we broadcast and say, who has 172 whatever IP address? I'm this IP address at this MAC address. What do they send back? Was it? Yeah, they send back, hey, they send back a response that says, I'm this MAC address and I'm this IP address. So when we think back to the protocol, what linked those two requests and responses?
The first person.
The IP address, right? So yeah, so when I say, hey, who has IP address, we'll say 10, I'm IP address 9, right? And this is my MAC address. And then when they respond back, they say, hey, I'm IP address 10 at this MAC address, IP address 9, here you go, and sends the packet back, right? So the two pieces of information that link it, right, are basically the sender's MAC address and the sender's IP address. Because that's how it knows to send the ARP reply back to that person.
Isn't there like a RARP request, like during the boot process or something?
RARP is reverse ARP, where you ask, I'm pretty sure it's the opposite, where you ask, who has this MAC address, tell me, and then they tell you their IP address. It's not used as much, that's why I didn't cover it too much. So what guarantees in the system or the protocol that we can't send an ARP request, a response before we receive a request?
You need the IP to send the response.
Yeah, we need to know the IP address, right? But when we're a machine, right, we send out a request, we get a response. There's nothing linking those two things. So if we just receive a response that says, hey, I'm IP address 9 on MAC address B, then we say, okay, boom, we update our table, right?
So can we broadcast ARP reply?
We can't, I don't think we can broadcast a reply. It may be ignored, I'm not 100% sure. But what we can do is we can try pinging or figuring out who's on our local network so we get that entire table, and then we can send each of them
Who has
request to say that, so essentially we're spoofing or poisoning their ARP caches and saying that, hey, that IP address you want to talk to is actually me, my MAC address. All right, so this is a super cool attack. Real quickly, so the goal is we want to actually, this is going to allow us to sniff all traffic in between two hosts on the network with this ARP spoofing. Basically, we tell victim A, hey, if you want to talk to victim B, it's my MAC address. And then if we tell victim B, hey, if you want to talk to A, you have to use my MAC address. And so this way, all the traffic goes through us, and we're able to impersonate and man in the middle all of that traffic. So we'll look at exactly how this works on Monday.